12-factor app development principle. Okay, so there are 12 golden rules. This was developed by a company called Heroku. Okay, they are majorly cloud native application development company. They provide lots of tools around this cloud native. Okay, so Heroku company basically designed this 12-factor app development principle for a well-performing microservice or a cloud-native application. No, it is not exactly. It should be able to deployable on the cloud. Okay, any code you write, you have a Java platform. You put the Java code, it is going to work there. It doesn't depend on whether it is AWS or Azure. But cloud-native is a concept. Okay, where the application should be able to use the advantages of the cloud. When I talk about cloud, the cloud can be either a public cloud or a private cloud. So what is the advantages of a cloud? Cloud is very, very elastic. That means whenever I need a server, I will be able to bring it up and I will be able to use it. And this will be done via a application call, right? I can just write a program to provision a server and that can be added to a load balancer. Okay. So when I talk about a cloud native application, the application should be developed in such a way that whenever it needs additional resources, it should automatically use these kind of functionalities of the cloud. It should be automatically scale up and scale down. Or I'm just giving one example. Cloud has other services, other solutions also, right? It has a object storage, it has a block storage. I can increase, decrease. I can make use of load balancers, and I can authenticate and authorate. So cloud native applications are nothing but these are the application which can effectively utilize the advantages of cloud, and it can act as a better performing application. So this is called as a cloud native application. And there is a community called Cloud Native Foundation. This is an open source community, and basically this is the community which is owning the Kubernetes. Kubernetes is developed by Google, and it was given as a donation to the Cloud Native Foundation. Okay, which basically talks about how I can effectively utilize the advantages of the cloud to host a better performing application. So this is the concept of cloud native application or cloud native foundation, what it is always doing to the market. Okay, so coming back to the 12-factor app, okay, let me walk you through the 12 rules, whatever they are giving. And not only in the microservice area, even in the monolithic area, we can follow these scenarios, which basically tells about best practices in designing application. Okay, so the first thing is called Codebase. So you should store the code in a single source of truth. Okay, so maintain a source control management system, and inside that store the code as a single place. Don't store it on every developer's machine, right? So centralizedly store the code, and in the microservice perspective, you should have it like either you can have a separate repositories for your individual microservices, or for application you have a separate repo, and inside that you can have multiple folders for the multiple services. So if you see that the Docker file, the best practice, whatever we have told, the Docker file should be with this single file name, that is Docker file starting with capital D, right? So for every service you have a unique Docker file, and for the deployment also you will have a unique deployment file available there. Okay, so maintain the single source of truth, that is maintain a code base, and inside that for microservices, for every service bare minimum have a separate folder for the every microservices of the application. Okay, this is the first rule they are providing. Okay, so the next rule is all about dependencies. Okay, so when you are designing microservice application, you should clearly define the dependencies of the service. That means let's take our internet banking application, where you are going to have the fund transfer application. The fund transfer application is dependent on my core banking system. It only can say that, okay, this is my current balance. I can transfer up to this much amount on this day. Okay, so without the core banking system, my fund transfer application may not work, right? So for my fund transfer application, that is a dependent service. But in the reporting service, let's say reporting service is not dependent on my fund transfer application. Okay, that for that the dependency is a different service. Okay, so whenever you are defining a microservice, clearly define the dependencies. Okay, and the next rule is called configurations. So any application, you will have the application configuration, right? So don't store the configurations as a file. The problem with the storing a configuration as a file, so mistakenly there will be scenarios you will be pushing the UAT configuration to production, production configuration to UAT. So I have seen a similar issue in one of the customers whom I worked with. So what they did, they have pushed a UAT configuration to the production, and at the time they were running a sale. They are an e-commerce based application. So there were 10,000 orders were placed, and there they have not got the money as it is pointing to a UAT payment gateway. So the 10,000 customers got free products. So those kind of issues, to avoid them, maintain the configurations in the environment variables, because environment variables only by the admins, not for everyone. Okay, so maintain the application configuration files on a environment variable. That's what we have shown in the Docker file also, how to pass the environment variables in the Docker. Okay, and the next concept is called, imagine if your microservice is having some kind of backing service. Like for example, there is an application which will be sync up the database from one database to another. Okay, or otherwise it can be a daily backup job which is taking the backup of the database. So all these things, don't run it on the service itself. Try to run it as a separate service. Okay, so if you want to sync up the job, run it as a separate service which is responsible for syncing up the data in between them. Okay, so these are all the so whenever you have any dependent services, so you should write them as a separate service, not with the main service, because in a database, if a backup is running, so the application, the data query speed will reduce, right? So you may get a lesser performance on the application. So always run the backing service as a separate service, so that the application performance is not impacted. Okay, and the next rule is build, release, and run. So maintain a build, release, and run process, so that you will be able to track when a deployment happened. Okay, what was the source of the deployment, and what were the changes has been happened in the deployment. So maintain a build, release, and run cycle. Okay, so let me repeat: maintain a single source of truth, clearly define the dependencies, and then define the configuration, application configuration in environment variables. If you have any other additional services, run them as a separate service, and then maintain a build, release, and run cycle, run process. The next rule is called map a service to a process. That means in Docker, what we are doing, there will be one running process that will be provided to the Docker container, right? So what they will do, so the Docker health is dependent on the service. So that service will be related to one process. Always run like that. Okay, so there will be a running process. Okay, and that process will be mapped to the container, so that your container orchestration platforms will be able to manage them. Because if the process goes down, okay, so the container will go down, my container orchestration platform will get to know that, so this service is not having any containers, so I can just bring up another container with the same image. Okay, so always map a process to a service. Okay, so the reason why this is very, very important is okay, the people who are starting with Docker tend to make this kind of mistakes. Okay, in our Docker example, what we did is we have created a Apache container, right? There we have created a script which will start the Apache in the foreground. Okay, I have seen what people will do. So they will start the Apache service, and to keep the container active, they will just give a command called ping localhost. That means the ping will be keep on running, right? But the application or the process that should be tied to the container is Apache. Even if the Apache service went down inside the container, as the ping is still running, the container will be still living. Okay, people tend to do these kind of mistakes in the beginning, so avoid all those things. Okay, so tie the process, tie the service to a process, so that will be the running process inside your container. Okay, and the next concept is called map the process to a port number. Like in our Docker example, we have seen Apache is mapped to port 80. Like that, you can map multiple services to multiple port numbers. For example, in our internet banking application, we will say that, okay, fund transfer is running on 80, check balance is running on 81, report is running on 82. So that when I want to communicate to the service, I'll be able to communicate with the port number easily. Okay, when I run this particular, when I connect to this machine on port 80, I will have the fund transfer running. 81, I will have the check balance running. 82, I will have the report service running. So tie a service to a process, and the process should be mapped to a port number. This is the another rule. Okay, and the next thing is called concurrency. Okay, so we talked about horizontal scaling right in the beginning. So your application should be able to run concurrently, then only you will be able to achieve the horizontal scaling. Like for example, you are designing application where two instances of the application cannot run parallelly, then you will not be horizontally scale the application at all, right? So whenever you are designing application, it should be able to run concurrently, then only you will be able to horizontally scale the application. Okay, so let me repeat from the beginning. Codebase, maintain a single code base, clearly define the dependencies between the services, and maintain the configuration in environment variable. And then if you are having any backing services, run them as a separate service, and follow a build, release, and run process, and tie a service to a process, and map the process to a port, and your application to run should run concurrently. Next is your disposability. Disposability is one of the important concept in microservice, not only in microservice, any general area where you are having the scaling up and scaling down is happening. Okay, not only scaling up and scaling down, this also comes into another scenario. I will explain that. So imagine your application is scaled up. So I have put a auto scaling rule saying that if the CPU usage of the machine or the average CPU usage of the service is greater than 80, I want to add one container to map the load. Okay, if the average CPU goes less than 80, it will automatically remove one container from the in the scaling method. Okay, there if the container is brought down suddenly, okay, it should be designed in such a way that the ongoing transactions or the data stored inside the container should not impact the performance of the application. I will tell you a real-time scenario. Imagine you are connecting to, okay, so imagine you are browsing to an e-commerce site. You have identified a product, and at that time you are connected to one of the web server, and you have added a product to the cart. Okay, so the cart information or the session information will be in the, let's say, web server 1. Okay, at that time the scale down happened. In the scale down, your web server was removed. Okay, let's say, and once you are connecting again, right, you will have the let's say you are taken to the web server 2. Okay, as the cart and the session information are available in the web server 1, your product will be missing from your cart, which is really not a good habit, because e-commerce platforms are designed to that you will order more. Okay, if you lost the product in the cart, you are not going to buy it, right? So that is not a best design in that way. In that case, what you will do, you will maintain the session in a centralized memcached kind of application, so that if the customer was taken to any web server, they will be able to see the session data and also the card details in the centralized scenario. Okay, so that is what it is all about, the disposability part. Okay, so even if this container went down due to the scale down option, or it's not only the scale down, it may be any other scenario where the container may go down because of some hardware issue or some application issue. Okay, anything can happen, but the ongoing transaction or the customer data should not be lost during the scale down or the unavailability of a container. So this part is called the disposability. So your application should be brilliant enough to maintain the transaction state irrespective of the state of the server or the container in which it is running. So the next concept is called dev and prod parity, which is very common in any infrastructure. Always maintain same configuration in dev and prod servers. That is non-production and production servers. Try to maintain a same configuration across all the environment. Okay. And the next thing is logs. Okay. Whenever you are writing a logs on the microservice or the container-based application, okay, write it only to a centralized system. Okay. You have to go back to the Docker scenario. In Docker, we have seen that the Jenkins application was printing the logs in the standard output, so that the logs will be stored onto the Docker server on the location where lib Docker containers, and there will be a inside the container ID, you will be able to see the log file. Okay, whatever it is getting printed in the standard output, you can see that. Okay, so I can write an application which will collect these logs, and the logs are centrally stored in a centralized section. Okay, that is where we have a component called EFK, Elasticsearch, Fluentd, and then Kibana. So Fluentd is the component which will be collecting the logs from every container. Okay, and this will be pushing it to a centralized Elasticsearch server. And Kibana is a graphing tool. Okay, so that will be connecting to my Elasticsearch, and I can create graphs out of the logs which are stored in the Elasticsearch. Okay, so this is the advantage. So you should always store the log files in a streaming format. Don't store the log files inside the container, so that if the container goes down, you will not be able to troubleshoot the application at all. Okay, and the last but not least, if your microservice is having some kind of admin process, let's say in your application you are having one admin service which will be managing the logged in user session, right? So if you want to delete remove a user session from the application, you can do it with the admin privilege. So those kind of things, don't club it with the application. Try to run the admin services as a separate service. Okay, so these are all the 12 rules you should follow when designing a microservice application. So let me repeat: you should have a single code base and clearly define the dependencies and maintain the configurations in environment variable, and keep the backing service on a separate service. Follow a build, release, and run process. Okay, and map a process to a service to a process, and map a process to a port number, and design your application which can run concurrently, and your application should be easily disposable, and maintain a similar environment on dev and prod, and don't write the log files inside the containers. You should write them on a separate system, and then or standard output. If there is any admin process available for the service, run this as a separate service. Okay, these are all the 12 golden rules of a application. EFK is a log monitoring solution for Kubernetes cluster. Okay, so it has 3 components. One is called as a Elasticsearch. Elasticsearch is kind of a database kind of application where you can give any unorganized data to it. It will organize the data and make it available for you. Okay, so the next component in the EFK is called Fluentd. So this service will be running on all the missions of the Kubernetes cluster. So it will collect all the container logs, okay, and push it to the Elasticsearch. So the Elasticsearch will index the data, and it will make it in a structured format for you to query. You can write a query in Elasticsearch, and that result of a query can be displayed as a graph in Kibana. So this is a EFK cluster. Elasticsearch for storing the logs and then normalizing the log. Fluentd to collect the logs from the container and push it to the Elasticsearch, and Kibana to create a visualization of the logs which are stored inside the Elasticsearch.